Hello everyone, welcome to this particular video tutorial. Uh, in today's video we want to talk about oxidation number or oxidation state. So this has to do with calculating the oxidation state of a particular element in a compound. So there are some elements that have fixed oxidation state and some have variable oxidation states. So in order to determine these variable oxidation states, we rely on the fixed oxidation states of other elements in order to arrive at that. So at first, let's define the concepts oxidation state or oxidation number. The oxidation number is just a hypothetical charge that an element or an atom will have when all the bonds that is formed between the atom itself and other atoms of different elements is considered to be ionic. So the oxidation state or the oxidation number is a charge, as we were saying, is a charge. So let's look at some of the elements that have a fixed oxidation state, like the group 1 elements, like hydrogen, lithium, then oxygen for example, and then the halogens. So all the halogens have oxidation state of -1. The group 1 elements have +1. Hydrogen has +1 except when it forms a hydride where it has -1. Then oxygen always have -2 except in peroxides where it has -1 as the oxidation state. So these are basic things that we need to know before we delve into calculating oxidation states of different elements. So these are fixed oxidation states. Let's look at examples of some of the compounds where we need to calculate oxidation state of some of the elements there. So like number 1 here, let's say in carbon dioxide, looking at carbon dioxide, you can be like, okay, yeah, oxygen have an oxidation state of -2 actually. So now to calculate it, we said oxygen is -2, then what's the oxidation state of carbon there? Say, okay, one thing to put in mind is that when you're having any compound, a neutral compound like this, then there is no any charge on the compound, meaning the sum of the oxidation state of this particular elements, all the elements in this particular compound is going to be 0. That means a carbon is not known, plus the oxidation state of oxygen will sum up to 0. So we don't know the oxidation state of carbon actually, but oxygen is -2, and there are 2 atoms there, that is times 2. So we have 0 here. That is x minus 2 times 2 is -4 is equals to 0. So by adding 4 to both sides, we have x is equals to 4. So the oxidation state of carbon in carbon dioxide is actually +4. So let's look at other case like hydrogen peroxide. In hydrogen peroxide, there are 2 molecules, that is hydrogen and oxygen molecules, and there are 4 atoms actually in this particular compound. So we said hydrogen always have +1 except in hydrides, while oxygen always have -2 except in peroxide. So this is hydrogen peroxide. Definitely oxygen is -1 multiplied by 2, which is equals to -2 for the 2. That is a +1 for hydrogen and then -2 for oxygen. So this is +2 minus 2 is equals to 0 because there is no any charge on that particular molecule. So in the case of lithium hydride, for example, a lithium hydride, in lithium hydride, lithium is group 1, hydrogen is group 1. So this is an example of a hydride. So lithium is +1 and hydrogen is -1, and the sum of the charges there is going to be 0 as well. So these are some of the few examples. Like, let's dive into more examples about how to calculate oxidation states of other elements that have variable. We have potassium permanganate. Potassium is actually +1 and oxygen is -2. So here we have manganese is unknown. Manganese is unknown. Starting by manganese, I can say, okay, unknown, that is x, plus oxidation state of this one is 1 multiplied by 1, and then plus the one for oxygen is actually -2 multiplied by 4. The sum of the oxidation states here must be 0. So here then we have x plus 1 minus 8 is equals to 0. Here we have x minus 7 equals to 0. By adding 7 to both sides of this, we have x is 7. That is the oxidation state of manganese, in potassium permanganate. And the oxidation state of iron in this particular molecule can be calculated as follows. Iron is X, and then chlorine is -1 multiplied by 3. That is X minus 3 is equals to 0, and X must be equals to 3. That's the oxidation state of iron in this particular compound. So looking at the third example we have in here for iron is Fe2 chloride. That's ferrochloride. Chloride. Then we have that's X times 2, like X multiplied by 2, and then minus 1 times 2, that is 2x minus 2 equals to 0, or 2x is equals to 2 divided 2 by 2, then x must be plus 1. That's the oxidation state in this case. Then the fourth example is chromium. I want to calculate the oxidation state of chromium here. So this is 3 here. So now the sulfate ion itself has a charge of -2 on it. Actually, that is the sulfate ion. You know that this one has a -2 oxidation state on its own, and that means for chromium is 2, then this one is -2 multiplied by 3. This is actually then -2 times 3, that is 6, is equals to 0, and then x here is going to be 6, and that must be oxidation state of chromium. Then for chromium in potassium heptaoxodiochromate, potassium is 2 multiplied by 1, then plus 2 multiplied by x, then plus -2 multiplied by 7 is equals to 0. That is 2 plus 2x minus 14 is equals to 0, and this one will give us a 2x minus 12 is equals to 0, divided by 2, divided by 2, divided by 2. Then here I have x minus 6 is equals to 0, which implies that the x here is definitely 6. So the oxidation state of chromium here and here are same. So that is all for this video. Thank you so much for watching.